The Precision Matthews PM-1340GT Taiwanese lathe has all of the precision of a 1440 Taiwanese gunsmithing lathe at just over half the cost. In this video, we're going to get the lathe out of the crate, assemble it, hook it up to power, get it degreased, and make some chips. We'll also go through all of the controls and give an overview of the specifications, feeds, speeds, and included accessories. Gavin Gu here from UltimateReloader.com. This is an exciting day at the Ultimate Reloader Mountain Shop. What we have here is the Precision Matthews PM-1340GT. I've been wanting to get one of these for a long time because it's a great machine from everything I heard, and it's very affordable, high precision, and a very good candidate for precision rifle, barrel work, and other similar gunsmithing. So what we've done is we've gotten this machine out of the crate. Just like all the other Precision Matthews machines that we've gotten, it was packed very well. It had a complete enclosure, which I unbolted, lifted the top off. We then unbolted this lathe from the pallet and got it set on the floor. We're on cinder blocks right now. The plan is to set this on the base with an engine crane, which is what a lot of you might try and do in your garage. So I wanted to demo that instead of using our backhoe with a kind of forklift configuration. Okay, so this is the stand. The stand is very heavy duty. I would recommend that you buy it. It's available separately. 3/16 inch steel. Moving the left and right hand sides into place to assemble this was actually a bit of a task because of how heavily they're constructed. This base comes with 6 cast iron leveling feet. I've already got the 6 leveling screws in place with the stop nuts backed off because we're going to do a leveling job when we get done. Okay, so what's left to do now is we're going to put the chip tray onto the base. We're going to get the engine crane ready to go. We're going to set it in place, bolt it together, move it into position, and then level it. Let's get to work. Okay, so that wasn't too bad. What I've got is a 2-ton engine hoist, and I extended the arm all the way out to the 1,000-pound or half-ton setting, which is fine for this lathe because this lathe weighs, I think, just under 1,000 pounds. So it's kind of pushing things a little bit, but the key thing is to get your spreaders in place. I cut 2x4s to 12 inches. 3/4 inch hardwood would be a little bit better because we had to do a double lift on the headstock side to set it down because the 2x4 was, turns out, too thick under there with the strap. Couldn't get it out from underneath. But you know, the key thing is to get your center of gravity correct, left, right. And so for us, that meant the strap's about right here. And lifting it up had plenty of height to get it onto the base. And after we set it down, I moved this carriage over and we put a spreader about right here in one strap just to get kind of the weight of the lathe off of the chip pan and off of the base so that we could get everything aligned. Got a couple bolts sent through, that kind of got us pre-aligned, and then we kind of just shook everything so that the rest of the bolts would drop through. Washers and nuts come up from the bottom to torque everything down. Good to go. So one thing to think about is I did use my backhoe to lift the lathe off of the shipping pallet and onto the ground. And that was so that I could straddle the lathe with the legs. The pallet was actually too wide. And we put it on cinder blocks. We're able to straddle the lathe and lift it no problem. So if you're in your garage and you're doing this with just an engine crane, you might need to use something like a chain hoist or something like that to lift it up initially just to get it off of the shipping pallet. You might also be able to do some sort of Egyptian method with a car jack or something like that. But for us, we got it set on the cinder blocks and that was all good to go. So the lathe is all together. All the bolts are torqued down. That makes me feel a lot better. And the next steps are going to be to get everything degreased, to get the machine broken in. I'm going to connect it to 3-phase power. I've got a drop right over here. I had a 3-phase Kearney and Trecker horizontal mill right here, so that's good. We've got the American rotary phase converter here at the shop, which is really why I moved it up here to get it all set up. So we'll hook it up to power, we'll get it degreased, and then I'm going to go over all of the standard equipment that came with the lathe, all of the extras like the DRO that I had put on, and of course, we'll do some machining. So I'm going to get to work. Well, things are coming along real nicely. Got some great updates to show you guys. I spent quite a while degreasing this side of the lathe. These gears take a lot of attention to detail. This time what I did is I just saturated the gears with WD-40, which acts as a really good solvent for this protective film, the anti-corrosion film that they put on there. And I used a bronze bristle brush like you'd use to clean a rifle very gently to scrub the teeth area, and kept saturating it with WD-40 and just took a miniature shop vac to vacuum off kind of the excess. You're going to want to take your time. These gears are now bare. I'm going to grease them up a little bit before I put the side cover back on for good, right? I also degreased the pulleys and also used lacquer thinner to clean off the belt. There was a little bit of sort of greasy residue on that. You can see here we have a quick release lever, and we can release tension on the belt, tension the belt, and just really quickly do that. This is going to take us from the high speed to the low speed range real quick, right? So another thing that I did was to get the machine hooked up to power. I had a drop right here. I used to have a three-phase Kearney and Trecker milling machine over here. So I made a whip and got the 3 legs hooked up for the 3-phase power. And fortunately, the machine is rotating the proper direction. Otherwise, you can take 2 of the legs and just swap them, and that should reverse the rotation of the motor. Okay, so I'm going to put the side cover back on, and then I'm going to show you the machine running under power. Okay, so I've got my rotary phase converter turned on. That's from American Rotary. We'll disengage the stop switch that turns on the power for the machine, and there we go. Go into the high range. Here's the top speed. That's 1800 RPM. The machine sounds really nice, and with 3-phase power, we should have slightly better surface finish because of a phenomenon called torque ripple that can happen if you're using single-phase power on a lathe. With a bit of tuning, my other lathes are running absolutely great with single-phase power, but I thought this time, since I do have 3-phase power available, that I would go with that. So with everything powered up, I took a moment to degrease this 6-inch chuck and backing plate. This is a really nice unit because you've got these screws here, which you can use to completely center the chuck, including for an individual work piece that you're holding if that dial-in is totally necessary. But with the repeatability of the jaws and the precision nature here, setting it once should be good. So let me talk about what's next. I'm going to mount the DRO display, hook it up to the scales. Those scales have already been attached. I would recommend, it's like $300 for Precision Matthews to do that. It's money well spent. If you have a bunch of time on your hands, you want to take that on, that's great. But it is a bit of a process to get DRO scales mounted. We're going to get the lathe up against the wall, get it back on the cast iron leveling pads, do a precision leveling job. Then with the machine under power, I'm going to degrease the control rods and the lead screw. And I'll continue to unbox all of the accessories that came with the lathe and also things that I've added to the lathe, like this nice precision 6-jaw chuck, and then we'll go over all that. Okay, so let's talk about gear that came with the lathe. That's everything right here, and stuff that I've added to the lathe. This stuff plus a couple things I'll mention. Okay, so the lathe comes with a nice red toolbox that comes with a lot of the small parts and accessories. We've got a headstock spindle reducing sleeve. This is Morse taper number 5 on the outside and Morse taper number 3 on the inside. And if you're going to turn between centers, you're going to need your centers. So here's 2 dead centers, one for the tailstock with carbide tip and one for the headstock that rotates with the work that doesn't need a carbide tip on that. So your headstock Morse taper number 3 dead center is going to go right in that reducing sleeve. We've got a double-ended wrench. We've got the gears for changing over to metric threading. A really nice Allen key set. I stole the 6mm off there for a Carriage lock. These are made in Japan. Really nice accessory there. We've got the 4-way tool post. This is one of the things on the lathe that I upgraded with the Precision Matthews BXA quick change tool post. And then we've got the tool here to tighten those. This can be a great setup if you're running a limited number of tools and want to quickly switch between them and don't want to have the complexity of a quick change tool post system. We've also got this really nice steady rest, really nice follow rest. We've got a face plate that's great for bolting work too that you need to turn, and for turning between centers. You are going to need a lathe dog for that traditionally. So this stuff all comes with the lathe. Standard package 1340 GT. Here's some of the stuff that I've added. I already mentioned the quick change tool post. I added the MagExact MX100L DRO installed by Precision Matthews. That $300 is money well spent to have it installed by them. And I love the DRO because it's got 2/10,000ths on Z and it's got 1/10,000th on diameter. It's a great way to do ultra precision work. It's got the physical buttons, really high quality DRO. Love it. Okay, you're going to need chucks. The PM-1340 GT does not come with chucks. So here I have the Precision Matthews 6-inch adjustable chuck. Now this comes in 2 pieces. You've got the backing plate and then you've got the chuck assembly. Those are ordered separately. This is a really good investment. The chuck jaws are incredibly smooth. It's ultra precise, but you've also got 4 adjustment screws so that you can pre-center the jaws. And then you can even go so far as to chuck up a piece of work and then indicate that and dial it in to run absolutely true. Really good investment, 3-jaw chuck. You're going to use it all the time. We've got a Morse taper number 3 live center for the tailstock. This is another piece of gear that I use pretty frequently if I'm doing things like polishing barrels on the lathe or something like that. We've got the Precision Matthews Ultra Precision Morse taper number 3 drill chuck. This goes from 1/8 of an inch up to 5/8 of an inch. I also like to have a smaller chuck if I need to chuck up something really tiny. So that's probably something that I'll add to the equipment lineup. Okay, here we've got the 8-inch 4-jaw chuck. This is just a good all-arounder, and for things like rifle barrel work, it's going to be a mainstay in the collection of equipment. So this is my initial setup of included equipment, added equipment. Again, we've got that quick change tool post and the MagExact DRO. With all this gear, I'm really ready to go. So for the DRO, here's what's included. We've got a few different components here. For this lathe, I had the MagExact MX100L pre-installed at the factory. This is going to be my 3rd MagExact DRO that I've gotten from Precision Matthews, and they've all worked super well. Okay, so the display is going to come in this. It's got this nice instruction manual, the display unit itself. This thing is cast aluminum. It's super beefy. This is not any kind of a plastic thing. I like the physical buttons on here. And if you look at the PM-1440 HVT2 video, we've got the same DRO on that lathe, and we get 1/10,000th on diameter and 2/10,000ths on the Z axis movement of the carriage, which is exactly what I'm looking for this ultra precision work. A little bit of mounting hardware. We've got the power cord, and then this is going to be the arm, and the bracket for the arm has been pre-mounted on this aluminum plate, and that's going to screw to the back of the lathe. So we'll go and do that next. It is time to make first chips with the PM-1340 GT. I've got my chuck mounted. The machine is completely cleaned up, including the lathe screw. We're leveled. I've set up 3 tools and put some round bar. This is aluminum round bar. It's 1.5 inches. And what I figured we'd do is we'd do a little bit of turning, threading, facing, drilling, maybe even a little boring, just to kind of try out a few operations as the machine settles into its level. So let's do this. There we go. That looks like a mirror. Wow, look at that. I did a little bit greasy. That looks really good. So let's face off the front here. I'm gonna up the speed a little bit. Why not? Like, go to 1 here. There we go. Now we're talking. There's our power feed here. Not the best tool for this. We're getting some chip crowding there. Okay, so I'm going to cut some thread reliefs. Okay, 16 threads per inch. Check our chart. 16, 4, and 8. Opposite there. Reverse our direction. Four and 8. There's 4. Nice. Oh yeah. Okay. Well, that was fun. This machine cuts great. You saw that mirror-like finish when we turned down the OD of this aluminum round bar. We did thread reliefs, threading, drilling, and then some facing on the end just to kind of try out some different moves with the machine. It all seems to work really good. The half nut engagement threading dial chart is a little bit different than what I'm used to, but I figured that out on the spot. DRO works great. So far, so good. Love it. So I wanted to give you guys a quick walkthrough of the PM-1340GT. We'll start on the headstock side, move to the carriage, and then talk about the tailstock. So at a high level, we've got 13 inches swing over the bed, and we've got 40 inches between centers, which is a great capacity for a general machine shop or for gunsmithing work, that kind of thing. So this is a gear head lathe. We do our speed changes with gear shift levers, and we've got a 2 horsepower motor that's available either single phase or 3-phase. I decided to go with the 3-phase option because sometimes 3-phase does just a little bit better with surface finish. Okay, so let's go over kind of all of our controls here. So we've got high and low shifting for speeds. We've got 1, 2, and 3 position speed selectors. And what we've got is kind of 2 sections on our speed chart here. The top section is when the belt change is in the high range, and that's the way that we've got it now. So that's gonna get us between 205 RPM on the low side and 1800 RPM on the high side. If we switch the belt position, which you can see indicated right here, we can go from 90 RPM up to 780 RPM. So here's the important takeaway from that is, if I'm doing turning and threading, I can do that all in the high range because I can thread either at 205 or 308 for most applications. If you have a real low TPI count and your tool is moving real fast, then you may want to thread in low range, but for the gunsmithing work that I do, that's not necessary. Okay, and then you've got your power feed direction change. Normally we feed Z, or this direction here facing towards the chuck, but we can reverse that by switching the lever like this. Now we'll feed the other direction with power feed for transverse on the carriage. There's also power feed on X for the diameter, and typically when we're in the standard mode, we're going to power feed in, but if we switch it to the right hand mode, it's going to power feed out, which is really nice if you're doing facing from the inside or doing certain boring procedures like that at the entrance of the hole that you're boring. Okay, so then we've also got the indicator lamp. If we turn off our power, we're gonna indicate that the machine is off, and this rotates to the right, the panic stop switch. That's how you turn the machine on and off, is the panic stop switch. Little rotation pops out. And then we've got the jog switch. So that, depending on the speed, is going to rotate the chuck at the rate that the machine is running at. And then down here, we've got two different modes that we select with this knob. We've got either threading or power feed, and there's two charts respectively. So if we're doing power feeds and we're feeding along the Z-axis, we can go from 2.1 thousandths of an inch on the fine side all the way up to 59 thousandths of an inch on the coarse side for a really fast feed. And for inches, for threading, we can go from 112 threads per inch on the fine side all the way down to 4 threads per inch, quarter-inch thread pitch, on the coarse side. And if we switch gears, we can also do metric threading. And the total range is, I think, 7.5 millimeters on the coarse side and 0.25 millimeters, it looks like, on the fine side. So that's kind of the headstock area. Let's talk about the spindle. The spindle is D1-4 mount, and it's got 1 9/16 through spindle capacity. You can see here I have round bar that's 1.5 inches. Plenty of room to get that through, and even to angle it slightly if you're doing some indicating, that kind of thing with an outboard spider. So the spindle capacity on this lathe is really great for traditional rifle barrel gunsmithing, where you're going to go up to maybe 1.25 inch shank on your barrel blanks that you're going to run through the spindle. The spindle length, if you were to take the chuck off from the front face of the chuck mount to the other side, is 13.75 inches. And that's one of the reasons I wanted to get this particular machine. Really high quality, all Taiwanese machine with a very short spindle means we're going to have more versatility when we want to do things like thread rifle barrel muzzles without taking off the action, and sometimes even without taking off the trigger. So now on to the carriage. So this is really the heart of the machine in terms of user interface controls. So for our cross slide, we've got 6 3/4 inches of travel. For the compound, we've got 3.5 inches of travel. Here's one of the things I really like about this carriage is that we've got inch and metric on our cross slide and on our compound. And when you're doing something like threading and you want to zero it out, you can just hold the dial and then sort of spin this. It has a kind of a friction lock and zero it out just like that. Really nice. The same thing here on the cross slide. And I do that with both every time I thread, because my reset position is going to be here even if I'm confirming with the DRO. And then where we start threading, when we're just touching the surface of the pre-turned OD, we zero there, and then we know what our in feed is incrementally as we go ahead and feed. So really nice setup there. We've got adjustable gibs on the compound and the cross slide. Already adjusted those and got those just to the level that I like, where they're slightly stiff, but they're not grabbing so hard that they're going to wear prematurely. We've got oiler ports all over the place here. Moving our way down, we've got the half nut lever. We've got a threading dial, so we know when to engage based on what kind of threads per inch or metric stuff that we're doing based on the chart here. Actually, I should note that this is an English lead screw, so if we are turning metric threads, we have to change the gears, and then we have to leave the half nut lever engaged. We have to stop the machine, back out the tool, reverse the machine, because metric won't realign with the lead screw, but English will, and that's what the chart here is for use with the thread dial. So we'll start the machine, and when we're ready to engage it, we just put that down. That's going to feed. So that's threading mode. And then if we want to go over to power feed mode, we switch this knob here on the headstock. Now we're going to see this guy turn. That means the gears are turning inside. If we pull this lever out and go up, we're going to power feed along Z. We can change that direction by switching this knob. Now we're feeding this direction. And then if we want to power feed on our cross slide, push the knob in and go down. That's feeding back, which is opposite what is typical. Again, we can switch that on the headstock. Go down again. Now we're feeding in. Quite a lot of options there for power feed and threads per inch. So far these controls are very familiar, very similar to the PM-1340GT, PM-1440HVT2, and really nicely put together. Okay, and finally the tailstock. We've got a familiar clamp here. We've also got a quill lock lever here. It's got 4 inches of travel and Morse taper number 3. We've got the Tang type tools that we're going to traditionally use in there. Really well put together, and again, very familiar, very much like the tailstock on the other two 1440 lathes that we've got. So as you can see, I've been using the PM-1340GT. I've spent quite a few hours at the machine now. One of the things that I did was to do some accuracy and alignment tests. The first was the tailstock and its alignment to the rest of the lathe. So what I did is I took a 1/10,000th indicator and moving the carriage back and forth, swept over the top of the quill, and that gives you this angle here, absolutely no angle, like within 1/10,000th of an inch over 4 inches sweep. Then I put the indicator on the side of the quill and swept along 4 inches as well, and was within 1/10,000th of an inch for that as well. So tailstock alignment to the lathe is dead perfect. I took off the chuck and swept the inside of the spindle and found this is probably the best result I've seen. Literally no movement on the needle for a 1/10,000th indicator. So spindle bearings are really tight and everything runs absolutely true. I don't even know how they do this. It's a pretty amazing result. So after those tests, I took the same 10,000th indicator, chucked it up in the 3-jaw chuck, and ran it side to side on the inside of the tailstock quill and adjusted the side screws to make sure that it was perfectly centered. So this lathe is now aligned absolutely perfect. I also did quite a bit more turning on the lathe. I took this 6-inch chuck and reversed the jaws. As you can see here, I've got a really good start on the outboard spider for the lathe. That's going to go over here. It's going to clamp on the end of the spindle. I'm going to have to modify the side cover, and that I'm going to follow up in the next PM-1340GT story. I've also got some tool trays I'm going to be attaching to the lathe and fabricating custom. So we're going to be focused on organization, tools, and readiness for chambering. So the outboard spider is a key part of that, and also machining a rigid reamer holder in place on the lathe is the other part, so that we have perfect reamer alignment to our barrel when we go to do that chambering job. So far, really enjoying the machine. As you can recall, we did some tests here. I did turning, I did threading. The threads look absolutely beautiful. And so far, really so good. And another thing that'll be next will be machining different materials. So when we do barrel jobs, we're doing 416R stainless, and we'll see how the lathe does with that. I've got some other tricks in store as well, so I hope you'll watch those follow-on videos. PM-1340GT, quite a bit less expensive than lathes like the PM-1440GT, 1440HVT2, or my TL1660. And it really has the same level of precision, it's just in a smaller package. There are trade-offs with less mass. You have to maybe take cuts a little bit more carefully at times, lighter passes for finishing. The 3-phase appears to work really, really well with smooth and consistent cuts, so I'm really liking that. If you have 3-phase in your shop, I would recommend getting the PM-1340GT in 3-phase. So I hope this walkthrough of the lathe and the basic demonstrations and the demonstration of the setup has been helpful. It's been a really fun process as always. Here's what I would like to know from you is, what do you think of the PM-1340GT? What do you think about how I set it up? And if you did buy one, or if you have one, what would you use it for, or what are you using it for? Drop a comment and we'll have a discussion down in the comments section. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. Thanks again for watching.